just to go straight into the presentation, actually. So everybody, we are all very much aware. I mean, I don't know, probably you guys are. Okay, let me even do like a very quick one, actually. Uh, let's say. So, I mean, I write code a lot. So, and I was very fortunate to write code before AI, and now I'm writing code, almost every time with AI. So, usually, when I write code, 40 seconds of, you know, just prompting can generate, hundreds and of lines of code. And the problem I noticed was that actually shifted my attention from just writing code into now understanding exactly what that means. And sometimes I actually spend a lot of time trying to understand exactly what the AI has actually generated for me. So, and that's actually the whole paradox now. And I'm sure a couple of people here are probably in the same shoe like me. So, uh, before before now actually, so you can just let's say yeah, so how many people here, maybe you probably like generated a code you don't understand sometimes. You can probably unmute your mic and just show me or probably just respond if you have generated a code using AI, or you measure code you don't fully understand, or if you are a developer or not a developer writing code with Codex, code, or any of these agents. Do we have anybody in the room in any of this
Um,
category?
I use Codex. I mean, people can even chat in the group chat. We can see how many tools are there, how many people are using as well.
Okay.
Yeah, because we can't do the hands up. It's not live
Okay.
session,
We can do it.
unfortunately.
Okay. All right, that's fine then. Yeah, I'll just move
Yeah,
on. Yeah. Yeah. So, and
a lot of
the
Codex.
yeah, okay, yeah, I really can't see the screen actually. Yeah, but that's fine. That's good actually. Yeah. So, and so one thing I really want everybody to actually take away tonight is that uh when writing code actually gets cheap, so understanding is now the bottleneck. So, and the old way of writing code before is we used to type, remember syntax, use boilerplate, remember APIs, and now AI are very, very good at these things. So AI has actually removed all of these frictions. And now the new bottleneck is slowly becoming reading the code, reviewing, trusting, maintaining, debugging sometimes. And this part, AI still tries to do a little bit of them, but at some time actually we need, I mean, AI even need us even more than never actually to do this whole debugging. And this is actually a change in the whole engineering, especially software engineering now. So, and the value uh, moves away from producing most line of code to actually understanding the best decision, refining the problems, um, understanding the solution that was produced, and also having a little bit of trust in the generated code. So is now more of judgment compared to author or people writing code actually. So and there was this experiment I came across recently. So the experiment was actually done by GitHub Copilot, in which they actually gave the GitHub Copilot to some developers to complete a project from scratch. So the task was actually for them to build a simple server, uh, and these developers they actually completed this code or task, faster by 55%. And also, it shows how much efficient AI agents are in terms of writing code. And also, the second experiment was done by MT, METR, so which they took some open source developer with large code base, large architecture, and they actually gave them the same kind of AI tools to write and write some features in their code base. And even though these guys they actually feel a little bit faster, they took time to actually deliver the task. And that will actually boils down the question that what exactly is taking time. So because these guys they understand the architecture of this large code base, they understand the convention, they check if these things actually fit in, if it's not gonna break, because a lot of thousands of people are depending on their project. So they took a lot of time from just writing code to testing to check if the architecture is actually aligning with exactly what they've been writing over time. And this actually shows the result. So the developers with the large code base, even though they feel like they actually faster in writing code, it took time for them to actually deliver because of these things. So the lesson here is not really about is AI making developer to be faster or making developer to be slower. It's just telling us there's a shift in productivity from just writing code now to understanding and having trust in the code base. So we need to also understand exactly where this AI wins and where the AI actually lose and the trap here. So most of the time, AI tends to actually perform well, do a very good job in new task, easy to verify. In a case where you need to build some MVP or some small project, so AI performs, deliver within seconds. You have your project up and running. Um, but AI tends to actually lose the moment the code base tends to be very large, the moment the code base is really mature, and most importantly, where you can't afford to make mistakes, especially when you work with high-stake projects, let's say some projects in finance, you just can't accept every single thing the AI is giving to you, and you need to actually make some pushback at some point. So, and the trap is like sometimes you feel like you're actually progressing so fast. Most people just feel like AI generating multiple files, navigating is like productive, but actually the speed is now, sorry, the the factor now is now not it's not really like the speed is now actually what is being delivered. Is it verifiable? Is it trustworthy? And do they actually is it maintainable? Does this actually scale when this project gets so big? Um, And also, there was another experiment or a research that was actually done recently. So that was done by GitClear. So they took large open source projects, like I think thousands of them actually. So and they observed the patterns in which has happened in the last 6 years. So and they noticed that in like 2020 2021 actually. So, and there's been a large numbers of increase in duplications of code. And also, they also noticed that 2024 actually has the highest time where there's a lot of pasted line of code actually. So it shows that the industry is definitely moving towards a certain direction. So, and they also observed that the stability also reduce a lot. So as the adoption of AI in most industry increase, there's a lot of stability issues, and I'm sure maybe few of us might have actually witnessed this in our day-to-day or maybe in one of the services that we actually use, where they just have a sudden downtime, and after the investigation, it's just because of some code production that they made, maybe with AI. Yeah. So, yeah, I will actually talk about a lot of patterns that I've came across myself while writing code with AI. And I'm sure maybe some couple of you guys will also testify to this, or if you haven't come across this pattern, you should be on the lookout for them. So these patterns are not really like the ultimate pattern, but they're like some fingerprints that the AI leaves behind code base, and people have actually observed actually. So, and this is actually because AI tends to write more compared to how much they actually delete. So, and the patterns goes across uh let's say dead code, duplication, isolated dependencies, and shallow failures, and the patterns are actually a lot. So while I was uh while I was building the project, the AI Slot project, I was able to come up even with more patterns actually. I think currently I've been able to come up with like 50 patterns anyways. I mean, with the help of AI, of course. Well, uh, yeah, let's just go into the details so that I can show you guys the real thing here. So, one of the things that is really common, um, it's dead code and offhand codes. So I'm not sure maybe you guys are familiar with this statement, but in software engineering, these are like something we I mean people are actually familiar with. So over time, uh, AI tends to produce a lot, so they try to find a way to produce as much as possible. In this example I'm showing here, so we could see that the AI is trying to write a function to actually pass state, and in the process, it's trying to make sure it's doing some time zone optimization and also some formatting, but maybe due to some poor context or some poor prompting, so it decided to just go straight with the date function. So leaving the two other functions as redundant actually. So these things actually compiles over time. So they tend to be unused code that actually, just compile up. It gives this kind of a false narrative to other developers or other engineers that wants to contribute to this kind of project. So they are not so sure if the time zone is being used or the formatting is being used. So unless you explicitly tell the AI to actually do this kind of cleanups, they will most likely just leave it there. And these are actually very hard for you to actually catch if you are writing. So if you are, just checking from the UI or from the browser or just testing the app, so these are like things that actually compile over time and makes your code base to be, I mean, to be, how will I say, I'm trying to look for the word, uh, to have this kind of technical debt over time. So another another one here is duplications and redundancies. So in this case, actually, it has happened to me quite numbers of times actually when I have a lot of functions around and AI tends to actually generate, based on the time when you actually start writing the code. So based on the current session or wherever, so it just goes straight into creating a new function, forgetting about the fact that this function can actually exist before. So the example here is also like a date function actually. So, but we are assuming that we actually have a util functions that have the functions for anything relating to date. But for the AI, maybe you moved away from cursor back to codex. It just decided to actually write a new function that does the same thing. So this actually happens quite numbers of times. Okay, I think you raise your hand up.
Yes, I was about to ask a question that there are existing tools which would uh, help with refactoring and there are existing tools, right? Can we integrate them with AI code or with any existing AI tools itself so that we can avoid these failures?
Yeah, yeah, definitely, definitely. Yeah. I will be talking about that later on today. Yeah.
Oh, I see. Okay, thank you.
Yeah. Yeah, that's good. Yeah. Yeah. So back to the stuff here. So duplication is like a very good thing. So I mean, a very common thing now. So I've seen instances where the AI writes like different validation for emails and all of this kind of thing, and they just tends to like compiles and cause this kind of redundancies and stuff over time. And also, a popular one is also the hallucinated dependencies. And these are cases where AI just tends to actually use some dependencies that does not really exist, or dependencies that are like not so safe, poorly maintained, or some dependencies that might be out of date or vulnerable. So it happens a lot. And I think there was a popular incident that happened with the NPM where there was a ransomware in one of the dependencies and it was chaining all around. And this was actually due to the fact that the AI just decided to install dependencies whenever it wants to. So to properly address these, there's a need to have uh permission to know exactly which dependency you are being used, the version, who is maintaining it, and is it a standard library or not, and is the AI is the code actually does it actually need the dependencies? Because there's some cases where uh we have tons of dependencies and none of this code base is being used. None of these dependencies is actually being used in the code base. And also, a popular one is shallowed failures. I don't know, probably you guys are familiar with these. So these are actually cases where AIs are like trained to be more on the positive side of things. So they go through the happy part of the response. So and once that is done, the rest of the errors are actually so sometimes they leave them empty. So sometimes they just return like null or something. So, and this actually causes a lot of problems, especially in cases where uh, something breaks in production. So you don't have a log uh, because the observability is not there. So you don't know exactly what actually fails in production. So, and this happens a lot and slowly just, makes debugging really, really hard for you. And at some point, you might actually just need AI to help you to debug these things. And yeah, just a very quick one. I don't know, probably you guys can spot anything here, but I've already explained most of the thing. So let's go to the other thing here. So we need to now move away from what looks good to uh, what exactly do you trust? So, and the shift has actually been from the author to the editor. So we, as the author, we type less, and uh, the AI, which is the author most of the time, so which is the editor actually, so does most of the thing. So the review, we have to do more of our reviewing and also to actually let me put that in. So we have to do more of a review in a way that we have more context and we can actually direct the way the editor is going to be, the way the AI agent is going to be giving us the output. And also the speed of feedback. So we need to also know that the value actually comes from how fast we can actually prove that this actually works. And we need to also move from the place of it runs to the place of I trust it. And this case is actually very, very important. So these are the cases where we just don't test the happy parts. We test with wrong input, test with failure handling. We check if observability is actually if the code base if the code is properly logging and checking for the right validations and all of this kind of thing. So, and that is actually where we come in. So we are now like the sacred resources actually, which we need to do the judgment. And here I will talk about the four P's. So which is like the purpose, the prompt, the proof, and also how to protect the code base. So here uh I kind of explained earlier. So we need to prove that we have tested the unhappy part. So we need to check in cases where we have a wrong input. An example is probably like email and password validation. So we need to check for cases of bad input, check for email patterns, and check for cases where the network is failing, and know exactly what breaks. And also, we need to uh, deeply not just skim through. I mean, these times AI explanation actually sounds so good. So, but we just can't assume and just take them. We need to like go straight into the dependency, check exactly what exactly is this dependency all about, and how recent is it being updated, and also uh we need to, I mean, not to like scrutinize the whole thing, but we just need to be able to like explain back exactly what kind of feature have you implemented with AI. So unfortunately, I mean, I've had some instances of cases where we've had people who actually implement a lot of features and can't even explain back exactly what is going on behind the scene about what they've actually implemented. So we need to actually understand exactly what we've done and how we can actually explain it back to other developers around. And for the protection layer here, so here is actually where one of the tool I built comes in. So we need to have linters, just like what Rohini was trying to mention. So we have a lot of tools out there that can protect us against these AI slopes around. So you check for linters, you check for the types, check for the security of dependencies that you are using. We check for dead codes using different kind of tools, and we make sure if we have a pipeline, make sure that your pipeline passes this check. And also, as we actually write code, it is very, very important for us to have uh, like a landscape of a verification layer. So here is actually some few examples of what I actually have in place that I do for myself. So I make sure like I treat uh, draft plan. I mean, each time I do plan mode, I always make sure I treat them as draft and just I don't take them the way they are. So I I make sure I have static analysis in terms of like checking for linters, checking for the types and formatting. I have quality gates. A very good example is a tool I built, and also check for supply chain guards. You could use different kind of tools out there, Sneak, and some other stuff like that. Yeah, so we'll give you guys some things to do. So in your code base, we'll give you a small challenge actually. So you don't have to do everything actually, just pick one of them and try to uh, do them as often as you can. So first thing, I mean, you can just try to explain the code back to yourself or to other people you're working with. You should make sure you test and also run on a happy path. check for dependencies, check for duplications, and add at least maybe one or two quality gates on your PRs, and also try to take your time to review your code base once in a while. And that takes me into the project I've been talking about, so which is AI Slob. So basically, I started building this project just because of these kind of issues I've actually come across over time while using different AI tools and agents. So basically, AI Slob it's a deterministic tool that checks for code quality. So it checks for dead code duplications. It checks for a lot of redundancies, hallucinated imports, check for bad dependencies. So I have been working on these for a couple of times now, and it's been having a little bit of traction. It's currently open source. You can have a look on GitHub, and if you are a developer and you really love this kind of thing, you can take your time to contribute and create PRs. I'm open to suggestions. So, and also, this also works in your CI/CD. So you could decide to actually add this on your workflow. And also, you can actually give this directly to Claude or Codex. So each time Claude or Codex is like writing a file, you keep them on check. And it's a very good way in such a way that you actually hold your agent and you hold your agent accountable. So each time they make a file, the questions becomes, is this duplicated? Is this maintainable? Does it have all of these kind of patterns? So, and you could visibly see the agent trying to correct itself. Yeah. So again, AI makes code writing to be very cheap. So we need to actually be the engineers that makes it trustworthy. And that brings me to the end of this presentation.
Ah, thank you, Kenny. We have a lot of questions in the chat. We can go one by one of it. I found interesting is that there was a business analysis stream mapping that question. The real gap in the business analysis requirement specs. Basically, I think any startup founder who comes from non-technical background, they'll have an idea in their mind, or they might have done a survey from customers. So they have a lot of feedback, and they're trying to build an application around it. I think in that stage, they're playing with different ideas or streams and developing a lot of code. So there is a lot of chance of redundant code being generated in the very beginning itself. So how can we avoid that? How can we make it better?